Hey AP Statistics, in this video we are in Unit 2 and we are going to discuss Section 3.1 in your book. In this unit we're making a switch from univariate data to bivariate data. So that means we're going to be dealing with two variables. And linear regression should be pretty familiar to you. It's something that you do in Algebra 2. So that is what we're going to be doing. We look at X and Y variables and see the relationship that they have, and then we create scatter plots and we do all kinds of fun things with them. So the first thing I want to talk to you about is the kind of variables we have. We have response variables. They respond to how the explanatory variable acts upon them. In other words, the explanatory variable seeks to predict or explain why the response variable is behaving the way it is. And so the response variable is y and the explanatory variable is x. That's how you can remember that. Okay, so when we look at a scatter plot, it's going to show us the relationship between two quantitative variables. We're not dealing with any categorical variables in this unit. So it is going to show us the relationship between these two quantitative variables. And of course, each item or individual that we've measured will show up as a point. So if you've got your XY coordinate plane, this right here, this would be an example of a scatter plot. Okay, it's just a lot of ordered pairs. And we want to see if there's a relationship. So there are a couple of different kinds of relationships we can see. We've got positive associations and negative associations. And when I use the word association, relationship is a good synonym. So I'm going to say there's an association between these variables, or I'm going to say there's a relationship between these variables. So it's positive, the relationship is positive when one of the variables increases as the other variable increases. And it's negative when a variable decreases as the other variable increases. So you'll notice one variable is always increasing. Well, that's going to be my x value. That's going to be my explanatory variable. All right, there's no association between two variables if knowing the value of one does not help us predict what the value of the other variable is going to be. All right, so when we describe a scatter plot, much like we described histograms and dot plots and other quantitative graphs in Unit 1, there are 4 characteristics we want to address every time. And they are direction, form, strength, and unusual features. Another word you can use for form is shape. Your book uses form, so I use shape because then it allows me to come up with a cute little acronym that will help me remember everything I need to talk about. So shape, is it linear or not? Those are your only options. So your scatter plot is either linear or it isn't. Unusual features are the same things that they were in Unit 1. Outliers, anything unusual. Direction, well, direction can only be positive or negative. And then, of course, the last thing is going to be strength. So in other words, how strong is the relationship between my two variables? All right, so when we measure linear association, there's a value that helps us determine how strong the relationship is, and that's called the correlation. It measures our strength and direction, so it will have a sign. It will either be positive or negative. And there are lots of properties about correlation that you need to understand. So I'm just going to quickly talk through what some of these mean. So it's always a number between -1 and 1. So that means that correlation is always going to be a decimal because our extreme values, -1 and 1, only occur when we have a perfectly straight line, which real data rarely produces that. Keep in mind that it shows me direction by its sign. If it's positive, that means a positive association. If it's negative, there's a negative association. All right, the closer the correlation is to 1 or -1, the stronger it is. The closer it is to 0, the weaker it is. And there are several cautions about correlation that we need to talk about. Correlation will not show me causation. In other words, it doesn't matter if my correlation is super strong at like negative 0.998. It still won't tell me that the response variable is being caused by the explanatory variable. So linear regression, the whole point of linear regression is to predict what we think might happen with the response variable as it responds to the explanatory variable. It is not about causation. A well-designed experiment is the only thing that will show us causation. Correlation does not measure form. So if you've got a set of ordered pairs that don't form a line, but they're really close together and have a strong association, you'll still have a high correlation, but we don't use them for anything other than linear relationships. So even if the correlation is really strong, it doesn't automatically mean that it's linear. That's what I mean by not measuring form. So you have to have a scatter plot or a line to go with it. All right, so correlation, of course, is not resistant to extreme values. It will drastically change if you have an outlier or something that lies outside the pattern of most of your data. And additional facts that we need to talk about. Remember, we're always dealing with two quantitative variables, and correlation makes no distinction between explanatory and response. So it can't tell if you've got the explanatory and response variable labeled correctly. Because R uses standardized values, R does not change when we change the units. So let's say I've got a set of data and I've measured everything in inches, but I want to change it to centimeters. The correlation will not be affected at all. It will be exactly the same. And the correlation also has no units of measure. So we're never going to say R is equal to negative 0.758 centimeters. Okay, we don't ever say that. So no units of measure for correlation. It's just a number.